Hi everyone, so we're down to our last two videos and these problems that we're going to talk about next, they're very similar to KEQ except we call them KSP to show that we're not doing chemical reactions here, we're doing ionic compounds that are slightly soluble in water. And we're showing how we have a saturated solution where we have stuff dissolving and stuff precipitating in the same container. And we're just solving for concentration. So it's called KSP instead of KEQ, or sometimes they actually call it KC. So I'm just going to write down here KSP and KC, they could equal the same thing. Now, like we said in the beginning, when we write a KSP or a KC or a KEQ. We never use solids or liquids in the expression. So here, if I'm going to do products over reactants, my products are my ions. And I have both of them, and there is 1 mole of each of them, so I don't have to square anything or do anything like that. And I would normally divide and put the reactants on the bottom, but since the reactant is a solid, I just actually ignore it. So yeah, my KC and my KSP, they're gonna be the same thing. Okay. Now the QSP again is the same thing where we do products over reactants, but just like we talked about in the KEQ, the quotient, the Q, is for when the reaction might not be in equilibrium yet. So if you were asked to solve for QSP, you would see if it matches the KSP and then decide if it's in equilibrium or not, that dissolving process, okay? But that's just, that's the same as last time. Okay, so let's take a look at a problem. So they want us to find KSP of PbSO4, and they're giving us this information about it, which is not a concentration. So we need to actually take this number times 10 to the negative 3 grams per 1 milliliter, and we need to change this into molarity. So how do I change it into molarity? First of all, molarity is moles divided by liters. So I want to get rid of milliliters, and I want to end up with liters on the bottom. Okay, so that's good there. And then it's moles divided by liters, so I want to get rid of that gram and turn it into moles. And if I look on my periodic table and I add up PB, S, and 4 O's, I get the gram formula mass is 303 grams. So I can cancel out my grams, and when I multiply across and then divide, I get 1.4 times 10 to the negative 4 molar. So that is the concentration. So now when PbSO4 dissociates into ions, I get Pb plus 2 and I get SO4 minus 2. So now what you need to do, guys, is you need to set up an ice table. And we're not going to include PbSO4 in the ice table because it's a solid, just like we talked about before. Okay? So before the dissolving process starts, remember, I don't have any products. My change, reactants turn into products, or you can think of PbSO4 as PbSO4 dissolves. What's going to happen to the number of ions? They're going to increase. So this is my plus side, okay? And then the equilibrium is your initial plus your change. So 0 plus x is x, and 0 plus x is x, okay? So now my KSP, I'm just going to write over here so I have room, equals the Pb ions times the SO4 ions, right? And both of those values are x's, right? So I'm going to plug in what I have. The only number I have for molarity is 1.4 times 10 to the negative 4. 1.4 times 10 to the negative 4. And that's going to equal 1.96 times 10 to the negative 8 molar. So that's going to be a concentration of dissolved ions in solution. Okay, so pretty simple. If you guys want to give this next one a try, maybe pause the video and give it a try yourself. You want to start by writing out I shouldn't say reaction, the process of this dissolving. What ions is it going to break up into? You want to change whatever they give you to molarity because you want concentration. Okay, so pause it, see where you can get from that, and I'll be doing it here when you get back. Okay, so 0.64 grams per liter. So I already have liters. All I want to do is get rid of grams. So 1 mole is 245 grams. Perfect. So I have moles divided by liters, which is molarity. Okay, so now if you guys set up your reaction, your PbF2 solid, breaking up into Pb plus 2 ions, and I have 2 fluoride ions, so that's important. ICE. Okay, so before I do the dissolving process, I have no ions in solution. As the PbF2 dissolves, the amount changes by x and by 2x. And then at equilibrium, 0 plus x is x, 0 plus 2x is 2x. Okay, so now let's do, oh, I gave myself a lot of room here. Okay, let's do my KSP. So my formula is going to be Pb plus 2, and then my fluoride ion, there's 2 of them, so I have to remember to square them, right? All right, so now I'm going to plug in what I have, x, 2x squared, okay, which equals x times 4x squared, which equals 4x cubed, okay? So now if I take, the only number I have for molarity is 0.0026, so I'm just taking that and I'm plugging it in for x. And guys, notice these tiny numbers that we're getting. These are compounds that are not very soluble in water, so that forward reaction isn't happening very well. So my products are not high. So I'm doing, a high number, a low number divided by a high number. So these numbers being small makes sense. Okay. All right. Let's do one more, and then I'm going to give you guys some practice in your worksheet packet. This is kind of like going backwards, where they're giving us this KSP and we need to find the solubilities, but you're still going to need to do the whole process where you set up an ice table and write out the reaction and things like that. So here I have calcium hydroxide dissolving, and it's making calcium ions, and it's making 2 moles of hydroxide ions. Okay, I'm going to set up my ice. As always, I start with no products. Once it starts dissolving, I'm going to end up with more ions in solution. And I have my 0 plus x is x, 0 plus 2x is 2x. Okay, so now over to the side, I'm going to just set up my KSP equals products over reactants. And as always, guys, with this dissolving stuff, I'm never going to divide by the reactants because the reactant is a solid and we ignore solids. Okay, so I'm going to plug in, I have KSP this time, 10 to the negative 6. My calcium ions are x, my hydroxide ions are 2x. All right, so 6.5 times 10 to the negative 6 is equal to 2x, I'm sorry, 4x cubed, right? And to get rid of the cubed, I want to do the cubed root of these numbers, and I'm going to just end up getting x equals 0.0117 molar. Okay, so the concentration of calcium ions is just x, so that's going to be 0.0117 molar. For the hydroxide ions, it's 2x, so we need to multiply that 0.0117 number by 2, and I get 0.0234 molar. And that's my answer. Okay, in your worksheet packet, guys, page 10 and page 12, they have one problem each on them, and they have to do with KSP, so give those a try.